Hi, welcome to NVMe in the real world. I'm Russ Stentfort at Facebook, and today we're going to talk about how NVMe really looks in the real world. I know oftentimes we see specs and documents and lots of different papers about many things, but today let's look about how this hardware really works and how it benefits us today. So let's start by talking about Facebook at scale. Today, Facebook has 1 billion users on Instagram, 1.3 billion on Messenger, and all told, 3.1 billion users use a Facebook product every month. That's a lot of people, and they depend on NVMe for storage to make sure that we have the most optimal experience for every user. That's very important. As you know, when you use one of our products, you want the very best experience, and that is something we're determined to make happen. Here you see one aisle and one data center, and you see there's a lot of hardware sitting there. Now with that, if we continue on here, well, what do these buildings look like? Facebook, as you can see, has built data centers across the world, and this is to ensure that our users get the best experience possible. When you look at these data centers, they're roughly 4 football fields in length, and they're housed with hardware of all shapes and sizes to ensure that everybody has the best experience. And that's a lot of people being affected by that. Now, let's talk about next generation form factors in E1S. E1S, what's really great about it is with the same PCB and firmware, it supports a diverse family of thermal options for the market. There's the high density 5.9 millimeter, all the way to the highest performance at low airflow 25 millimeter E1S. And what's really great about this is a single PCB firmware, and it's just a thermal option that gets added on to the drive. So depending on what you build, you have great flexibility. It supports performance scaling with PCI Gen 5 and beyond, hot plug. It's excellent for both storage and compute in 1OU, and has very broad market support, as you can see by some of the drives at the bottom of this picture. Now, let's talk about scalable and efficient NVMe platforms. If we start here on the left, you see the 25 millimeter E1S latch. This is really great. As you can imagine, when you have lots of hardware in a data center, it's really hard to maintain, so we want to make sure it's really easy. So by having a nice flexible latch, you can pull the drive out when it fails, push it back in, really fast, really easy, very convenient for maintaining your data center. Then, as you can see, on the left, there's a 4OU chassis with 1OU blades. On the right, there is a 2OU chassis with 2OU blades. As you can see, these chassis are 4OU high, and they support very dense storage. If you look down here at the table, you see the max blade capacity for the 1OU blade is 64 terabytes, and for the 2OU blade platform, it's 96 terabytes. This leads to 768 terabytes for the 1OU blade platform and 576 terabytes for the 2OU blade platform. In addition to that, they're very efficient. The CFM per watt is very low, making it very good for the environment. Now, what do hyperscales care about NVMe? What are the requirements? If you go to Open Compute, you'll see the NVMe Cloud SSD specification. A link to the specification is below. This is a joint effort between Facebook and Microsoft in speccing what are the NVMe requirements and what do we need and how do things need to work. And for more details about that, let's talk about that. This document is roughly 70 pages of requirements of what's needed to build an NVMe Cloud SSD. Includes requirements around NVMe Express, PCI Express, smart logs, reliability, thermal, power, security, form factors. Everything you need to successfully build an NVMe Cloud SSD is covered in this document. And it makes it very convenient to know exactly what you need to do. And with that, Facebook, we're building innovative and highly efficient data centers using NVMe technology. And I want to thank you very much for listening today and hope you have a great time at Flash Memory Summit. Thank you.
Good afternoon, folks. Welcome to the NVMe Fabrics in the Enterprise presentation. at the Flash Memory Summit. I am delivering this virtually, so I'm missing all of you guys. I always love coming to the Flash Memory Summit every year, and usually I'm making a presentation or two. So I hope you enjoy this presentation and send me some feedback if you have any questions, etc. in the end. So my name is Rupin Mohan. I work for Hewlett Packard Enterprise, and I'm currently the Director of R&D for Storage Networking. So what we have on the agenda today is start with some data center trends, what we are seeing in the data center in the enterprise for next 3 years, and then we'll go into a little bit more deeper dive into what we see is coming down the stack, the new IO stack around NVMe over fabrics. Further on, I have some thoughts around how the different protocols are going to be sitting in the hybrid cloud. We all should be now very well aware of the hybrid cloud and kind of converge on the thinking that the world is going to be more hybrid, and start designing solutions for that particular deployment scenario. I definitely will spend a lot of time on the centralized discovery controller. This is a lot of work that's going on in the NVMe group, and we'll go in a little bit more detail and kind of introduce you guys to this concept. This is new development going on, so you guys will enjoy. And also there's an opportunity for technologists to participate and kind of shape the future when it comes to NVMe over fabrics. And then in the end, quickly, next steps, final some takeaways from this presentation. Once again, thanks for dialing in, folks. So let's jump into the data center trends. What I'm seeing and what we believe is that there's a ton of disaggregation happening in the data center, and it's kind of a loaded word. It means different things to different people. From my perspective, from the enterprise perspective, if you look at the enterprise and how we've been selling shared storage and how we've been selling enterprise storage, what you've seen is that all the compute servers are in a rack. There's a couple of top of rack switches, on the top, and they're connected to either single hop or multi-hop fabric, connected to storage arrays, usually end of the row or in a room in the data center where all the storage arrays are consolidated. What we are seeing and what we will see in going forward is more of a disaggregated approach, and not like this traditional approach of having storage being kind of in the corner of the data center or the end of the row. The tenets of this new disaggregated model are they're all workload driven. We all understand now that storage is very workload driven, and we have when you look at the different solutions out there, whether they're file or block or object, a lot of the different you find that there are a lot of different options for customers to deploy different types of storage solutions for different workloads. So what we're seeing and what I'm saying is that in this disaggregated data center, you will find that there'll be compute instances, network instances, storage instances, kind of spread all over, and they will be more workload driven, meaning you'll have a pod that's particular designed for a particular workload and deployed in a certain solution type, and then you'll have a different pod with a different workload. And some of these workloads will be on-prem, some of the workloads will be hybrid, and some of the workloads will be on the cloud, right? In terms of network connectivity, we are looking at new technologies coming down the pipe. 200 gig is coming, in this year and early next year. 400 gig is right around the corner. So in terms of network bandwidth, right? We're seeing big fat pipes that are going to be coming down the data center. So network bandwidth will be will be required. A ton of network bandwidth will be required to be able to disaggregate the data center. Traffic, especially when you look at storage traffic, it'll flow east, west, north, and south, and there'll be no such boundaries as such in this new model. Of course, latency is the key, and we are looking at NVMe over fabrics. The key tenet of NVMe over fabrics is extremely, extremely, extremely low latency, making it rather transparent from a customer and data perspective. Whether the data is sitting on the PCIe bus on the server or is it on fabrics over a distance, latency will be extremely low, and the goal is to make it sort of transparent. And then on the bottom, again, software defined is going to be the future. A lot of it will be software defined. Of course, there'll be purpose built storage arrays, and that'll be continue to be very popular for tier 0 and tier 1 architectures. But a lot of the different new models will be on software defined. And then on the bottom, like I said, it's automation, orchestration. Customers will always want industry standards and not kind of lock themselves into proprietary solutions. Security remains one of the key tenets in this new model. It becomes even more important in the disaggregated model. Scalability becomes key as applications scale. People want storage solutions that scale. And of course, TCO and cost of ownership are going to be also, people want the cloud-like experience. The one thing the cloud has taught us in this hybrid cloud is that customers want that agility, they want that ease of use, they want the simplicity, and they want to be able to manage their infrastructure really from a single pane of glass and in a very easy manner. So continuing with our disaggregation mindset on the data center, even on the storage side, storage inside the servers, we see that a lot of these NVMe drives are kind of underutilized and kind of trapped in these individual servers, direct attached kind of model. We also believe that a lot of the storage will be consolidated in a JBOF or a JBOF type of use case, where customers will be able to easily expand the storage, will be easily able to add, remove these NVMe drives, and not having to go to individual servers to be able to manage these drives. And all these new model of aggregating all these NVMe drives in a JBOF, they'll all be connected through fabric switches, Ethernet fabric switches. The value proposition, I think, is going to be very clear in this one, because customers will be able to utilize more of their storage arrays. Also, they'll be able to have greater access to their storage with HA and multipathing capabilities built in. And then, of course, the whole TCO angle of lower costs, from a solution perspective. So this is another very big trend we'll see in the data center in the next coming years. So from a new IO stack perspective, I think people, I always use this analogy, about moving from gasoline engines to all electric engines, and then the hybrid engines in the middle. We've seen this transition over a period of 10 plus years in the automobile industry. I think in the NVMe land and storage, this transition is going to be much faster. We are not going to take a decade to go to quote unquote all electric or end-to-end NVMe storage solutions. We are already seeing pretty much every solution today is a sort of a hybrid solution in the market, where some pieces of the stack is running SCSI, but the drives are NVMe drives, and there's some sort of translation going on. And these arrays are very software rich. As we move to the next generation arrays, you will find that everything will be end-to-end NVMe controller, front end, back end, and then the software features will have to be re-architected for the new protocol. So if you look at the stack, it's a pretty changes have to be done across the stack from top to bottom, and a representation of a typical fabric attached Ethernet storage array is represented here. And as you can see that pretty much we have to incorporate NVMe in every layer of the stack. The applications have to take advantage of the RDMA functionality that NVMe over Fabrics brings to the table. The volume managers have to be optimized for NVMe. Of course, the driver stacks on the operating systems have to be developed, which, by the way, is very time consuming and a tedious and effort that our OS vendors have to go through. And we are starting to see, of course, Linux is already out there. Pretty much all flavors of Linux have a well-developed NVMe over Fabrics stack, but we are seeing, other operating systems also getting together their stacks, around NVMe. And of course, you have to have the right fabric switches, and we'll talk more about the different options in a slide or two. And then on the array side, again, there's a lot of development that has to happen on the front end host port side, developing all these different stacks around NVMe, and of course, on the back end, with the NVMe drives, the stack on the arrays also have to be kind of contemporized. So, quickly, on the use case side, a lot of you guys are storage guys. You've been around for a long time, and if you guys remember, 10, 15 years ago, we had fiber channel arbitrated loop in the back end, with fiber channel drives, in the back end. So the same concept kind of comes back with NVMe. You have, a front end fabric and a back end fabric. But of course, with such high speeds coming along, with and of course different fabric options, you'll have a different options for front end and back end fabrics. In my particular opinion, I believe that homogeneity in front end and back end of the fabric will be key in bringing a very interesting customer solutions, in bringing more value-added customer solutions to our customers, and we can discuss that later on in the presentation if we have time. But keep in mind that there will be a front-end fabric and a back-end fabric that customers will have to design for and plan for. Different use cases. I'm not going to spend a lot of time here, but kind of gives you an idea of how these different use cases are progressing. Very similar to what we did, when shared storage came into play, 15 years ago with Fiber Channel, right? When we were able to connect, Fiber Channel over, storage over a distance using Fiber Channel. Same concept is happening around NVMe, where we are now going to coming out with more interesting solutions around connecting NVMe drives over a distance over a fabric. And there are different types of use cases customers will be able to deploy. The one thing that I will kind of focus on a little bit is on the use case number 3, is that especially in the software-defined world, in the world, a disaggregated world that I talked about in the beginning, when you have a disaggregated data center and you have software-defined stacks that are fine-tuned to separate different kinds of workloads, the use case number three becomes very popular, where you have a JBoss connected to these type of fabrics, Ethernet fabrics, usually and connected to these servers running these software-defined stacks. I think those are the types of use cases that are going to be becoming very interesting with NVMe over fabrics in the next 3 to 5 years. Moving along, so this is a question that I get asked every time I talk to a customer or I talk to a partner, which we do a lot at HPE. HPE is talks to we have what 80,000 plus channel partners out there, and we talk to a lot of different technology partners also. One of the questions they all ask me is, hey, which protocol do you think is going to be lie in which particular use case, and also how do we prioritize this? So what I believe is that Fiber Channel is going to continue to remain popular for that tier 0 on-prem use case in the hybrid enterprise, where customers who want that solid reliability, scalability, and that tier 0 availability, they will want and continue to leverage their existing infrastructure they've spent millions of dollars on, and they like to move towards more like an FC NVMe scenario in terms of fabrics for their storage connectivity. For customers who are more hybrid use case or more tier 0, tier 1 use case in the hybrid enterprise, who want to be able to have a little bit more flexibility to move their workloads across the data centers in a more disaggregated fashion, they are going to be looking at Rocky V2 and TCP as their transport of choices. And then the next question that everybody asks is, where do we focus on? Whether do we focus on the Rocky V2 case, or do we focus on the TCP case? TCP protocol as a deployment protocol, and which is going to be popular. And the answer, of course, is, as an engineer, right? The best answer you can always give is, it depends, right? It depends on what your particular workload is and what particular use case is. If you want that super low latency, not a huge fabric. It can be multi-hop, but it can be 7 hops like we do support in Fiber Channel. If you have a relatively contained, use case where you can have a small type of fabric or a reasonably large fabric, not a huge fabric, I think you can deploy it, with Rocky V2 and get that super low latency, ultra high performance. But if you don't have that requirement of having that super low latency and super high performance, I think TCP is going to be a huge dominant player in this market. And you'll find that from an ease of use perspective, NVMe over TCP is going to be much more easier to use because it takes a little bit of knowledge to configure a Rocky V2 fabric, which all vendors are coming up with solutions to make Rocky V2 easy to deploy. But NVMe over TCP is much more forgiving, that you don't have to go and make those configuration changes, and also you don't need those switches that can support multiple priority levels and multiple priority code points. In terms of InfiniBand and IWAP, I don't think that these will be have much of a place in a hybrid. Now they do have a place maybe in the back end of a fabric, in the back end fabric from a storage perspective, but I think those will be very, very limited. I believe that the market will kind of converge across Fiber Channel, Rocky V2, and TCP, and I've talked about the different use cases for those 3 protocols. Let me move along to this whole concept of centralized discovery controller that we're working on in the NVMe group. So I just wanted to put together one slide on what is the problem we're trying to solve, and what we discovered in the NVMe group is that there was a lack of centralized discovery service for servers, hosts, and storage devices to be able to have a single location to get all the consolidated information. So in terms of from designing a scalable NVMe over fabric solution, right? A lot of the configuration was had to be done manually, and it was a little bit of a complex method of discovering all the different storage subsystems out there. And there was no standardized mechanism also to share information between all the discovery controllers in the NVMe IP-based fabric transport. So, I mean, this effort around the centralized discovery controller is, for the Ethernet storage fabric. So I want to emphasize that because, we do already have a name server on the Fiber Channel fabric. So Fiber Channel really does not have this problem of not having a centralized discovery controller / name server. So the problem we're trying to solve is particularly for Ethernet fabrics, which we believe is going to be, a huge problem. Other things that we think that we're missing in this Ethernet fabric, for NVMe fabrics, right, is the whole capability of being able to do some sort of resource management that we are able to do with Fiber Channel soft zoning, etc. And the last point around is the fabric generated events and notifications that we were also, I think, missing in today's solutions. So I think the industry got together and there was a great teamwork that we are seeing today across all the different active members. We have members, of course, from HPE who kind of introduced this topic and this problem statement to the group. And very quickly we got interest and active participation from vendors across the industry. From Dell EMC, NetApp, Intel, Lightbits, Mellanox, Marvell, VMware, Samsung. So I mean, this is a nice broad group of folks, engineers, 30 plus engineers who get together every week and make a lot of progress in solving this problem. So the group got together, and there are basically two technical proposals that are under development in the Fabric and multi-domain subsystem NVMe Express task group. The two proposals are 8009 and 8010. And I'll briefly, talk about these two proposals in this slide, and then go in a little bit more detail in the next two slides. So 8009, TP 8009, basically delivers and designs an automated discovery mechanism for discovery controllers, using the MDNS and DNST protocols. So the group, has a lot of experience in protocols. So they didn't want to, reinvent the wheels when they don't have to reinvent the wheels. So, servers can use, MDNS query, and a discovery controller can respond with its IP address and transport supported. So the host can very, easily connect to the subsystems. Also, TP 8010 can use the mechanism defined in 8009 to discover and query a centralized discovery controller for Ethernet fabrics. And of course, maintaining compatibility with existing implementations in the standard is one of the key tenets in anything we do with protocols and standards. 8010 again uses 8009 to MDNS mechanism to discover the CDC. Then the CDC, it goes on to define how the CDC aggregates all the discovery information for all the NVMe fabrics, hosts and subsystems, and kind of groups this and gives the capability for admins to group this information, and provide some access controls for visibility and resource management. And of course, the centralized discovery controllers also can generate fabric events to report any changes in the fabric. So moving along, in 8009, a little bit more detail, the group came up with this automated discovery mechanism using existing protocols. But the group defined basically three types of use cases. The direct connect use case, a single broadcast domain use case, and the multiple broadcast domain use case. And basically, whether it's the DDC, which is the direct discovery controller, whether a host is trying to discover a direct discovery controller, which is embedded in the NVMe OF storage device, they can do that, or they can even use this mechanism to discover all the DDCs in a single broadcast domain, without having the need of a CDC, which is a centralized discovery controller. And then, of course, they can discover the centralized discovery controller in a multiple broadcast domain situation and a use case, which in case where the fabric is much, much more bigger. And it doesn't really matter what transport customer has deployed their NVMe fabric storage solution. It could be based on Rocky V2, or it could be based on TCP or any other protocol that the NVMe fabrics group has defined and as supported. And this is just a line diagram for TP 8010. It kind of goes through and in a nice pictorial fashion kind of introduces the concept to all of you, where how servers and subsystems can discover the CDC in the fabric, and then how they can go ahead and register themselves into the CDC, and then customers can go in and then go into the CDC and do whatever resource management they want to do in terms of zoning, etc. And then further along, when customers have to go ahead and do the discovery of the devices, they can go and basically get the same sort of discovery, get log pages command and get that information from the CDC, and then therefore connect to the subsystems and then discover all the namespaces And this makes this um, um, very easy for customers to kind of deploy NVMe over fabrics, which was kind of missing in the standards today. So again, I want to emphasize for both 8009 and 8010, the implementation details are in the standard and they are still work in progress. I have permission from the group to share this information with you guys so that we can start to kind of let the folks know in the industry that we are working on these protocols. Participation is more than encouraged. So if you guys want to come and participate, you have to be part of the NVMe Express group. Your company can join, and you can more than welcome to participate in any one of in the development of these two technical proposals. So this is my last slide, folks. What are the key design takeaways, and what are the key takeaways from this discussion today about NVMe over fabrics in the enterprise? NVMe over fabrics, I think, in the enterprise, gives the customers to deploy NVMe over fabrics in a lot of different ways. The beauty about the enterprise is that customers get an opportunity to design their infrastructure according to the way they believe it best serves their business. So NVMe over fabrics SAN does give you the opportunity to design low latency, high performance, disaggregated storage architectures that are designed for your particular workloads. So you can have different types of NVMe or SAN deployments for different types of storage architectures and workloads to meet your business needs and to meet customers' business needs. The hybrid cloud enterprise is real and is the future. We all should, kind of agree to that it's not a winner take all market out there. And then, from a storage perspective, low latency and high IOPS is the name of the game. And I think everybody can agree to that also. The Ethernet storage fabric, I think, is going to be key for the hybrid cloud, especially when you're talking about connectivity from the on-prem to cloud and being able to move workloads, from on-prem to the cloud or from the cloud back to on-prem using cloud volumes or not, depending on what your solution is. Again, Ethernet fabric is where the future is going to be, for this hybrid, quote-unquote, hybrid cloud deployments. And that is why we are focused on making it easy for our enterprise customers to deploy Ethernet fabrics with NVMe over fabrics and whole concept of the centralized discovery controller. And then I really would like to take 1 second here to thank all of you for taking the time to listen to me and my presentation. And you can reach to me. This is my email address, rupin.mohan@hpe.com. I want to give a shout out to my co-workers, Babu and Curtis, who are driving a ton of this work in the NVMe Express group. They're both part of my team. And we work very closely with all the different vendors in the industry. And so please reach out to me if you have any questions. And thank you so much for tuning in. Bye-bye.